Hello, mildew. Good evening to you. Well, I was trying to figure out what felt off. I know. I shaved. I needed to just mix it up a little bit. I just had to mix it up. How's your Monday treating you? Hello, Amin. Pretty good. Not too much of a crazy week. Good. I hope you guys can get some rest in the midst of the crazy semester. Is the MAE lab remote again like last year? It's half and half. We have some things on campus and some things remote. Will MAE 436 be offered online? No. No. 436 is going to be in person in the fall. Is that good or bad news for you? Oh. I was really looking forward to building the ball sorting machine last year, but COVID happened. Yes. I know. Are you going to upload a Dr. Estes cover of any songs? Maybe. I mean, what do you want to hear? I mean, gosh. There's so many options. Hello, Dr. Estes. How is it going? Hey, it's going well. It's 7 p.m. and the sun is out. And that makes me happy. And that makes me happy today. Look at these goodies. Let's get a little bit of tunes going. And then we're gonna run through the Servomotor workshop, which I think this week it's a fun workshop. It's not too long. So, should be fun. We're rocking the chill hop tunes this evening. All right, let me pull up this workshop. Where'd you go? Okay. You guys ready? Let's start by attaching all this stuff. We're going to be building this circuit. And I'm using the tiny breadboard today. I like this one a lot better. It's easier to get the jumper wires plugged in here. All right, so you're gonna need your servo, number one. Did you find your servo? Mine looks a little different because I took it apart because I wanted to look at the insides. You're just gonna need your servo. You need your potentiometer, which we haven't used this one in a couple weeks. Do you still have it? I hope you do. Let's connect this potentiometer to the board. Yeah, that goes in so much easier than it did on the other breadboard. You want to connect this like across the middle. And we're going to plug in the 5-volt power source. Is this a Christmas song that I'm listening to? This is the Nutcracker like lo-fi remix. We're not going to do that. It is not Christmas anymore. Okay. The potentiometer was really hard to put in the first time it was used. The connection was not very stable. Yeah, I think you'll find on this breadboard when you get it in there, it is much more stable. I prefer this one a lot more. Okay, and then next. We're gonna go from the 5-volt pin. Come on, buddy, you can zoom in. It's always a struggle. Yeah, we're gonna use the 5-volt pin, connect it to this top leg over here. And then I'm gonna take a blue wire. I mean, it doesn't matter which color. Does that breadboard hold the relay better? I don't think it'll hold the relay better, unfortunately, because the relay, the reason that doesn't plug in, we're plugging this one into the second leg of the potentiometer. The reason the relay didn't plug in was due to the spacing of the holes. And if you compare the two breadboards, the spacing is identical. Like, if I get these next to each other. Yeah, it's like, it's exactly the same. So unfortunately, the relay is gonna have the same exact problem. I think. All right. And then on this lead over here, This is the signal output of the potentiometer. I'm going to put another cable right in that same row. And then we're going to bring that cable back and plug it into analog channel 0. So this is the potentiometer. And for the first couple servo motor exercises, we're not even going to use it. But when we get to the third exercise, we're going to want to have the rotation of this potentiometer match the rotation of the servo motor. So we're going to be sending commands from based on the position of this. All right, let's attach the servo. Not too much to attach today. Okay, we got the servo. 3 wires coming off. You got brown, which is the ground. We have orange, which is power. And we have yellow, which is what we're going to send the angle commands to the servo motor through. So what I'm going to do, I'm going to take a red wire, attach it to the red. And this is because I want this male end. All right, let's get for this brown wire, which is ground. I'm actually going to use blue because I was using blue for ground. And for the last wire, yellow, I just happen to have an orange one right here, so I'm using that. Now the power, the red, that's going to go to the 5 volts. Now come back over here. I already have 5 volts going to this row of the breadboard. So if I want to send 5 volts to the servo motor, I can just take this red 5 volt line to the servo and plug it into the same row as the potentiometer. So I'm just going to get it right in there. Okay. And then the ground is going to this leg of the potentiometer. And I can just attach the ground of the servo right there too. So this is the nice thing about the breadboard. You can have multiple devices kind of sharing the same connection. And the connection point is just spread out across each row of the breadboard. Okay. Now we just have one more cable left on the servo motor, and this is the cable that the Arduino is going to communicate with the servo motor with. And I'm going to send this to digital pin 9 over on this side. There you go. And my friends, that's it. That's all the wiring required today. Got the servo, we got the potentiometer, and we're going to use this setup for all of the exercises. So the first thing we're going to do is we're going to upload sample code number 1. Where'd this thing go? So we just built this circuit. There's another picture of that same circuit. Oh, wait. This is the first exercise. We're just going to upload a sample sketch that moves the servo to different angles. So I got to find my trusty USB cable. It's buried under like piles of books right now. There we go. All right, let's connect the USB. And whatever code you last had on your Arduino, that's what's going to load. That's what's going to load up and start playing once you plug this in. All right, let me find the sample code. Sample code, servo sample 1. Let's open it up. Here's the sample code. All right, I'm just gonna upload this and then I'll explain it. So we go to Tools. I find my board here, the Uno. Find the right port. Then we just click Upload. Now let's watch what the motor does first. You can see it's kind of jittering between different motions. Let's compare that to the code. Okay, so we're using the servo library. It's alive! I know. It's alive and dangerous. No, it's not dangerous. But the servo library allows us to use, well, we only use two commands, really. We use the attach command, and attach attaches the servo to a pin on your Arduino. So I attached it to digital pin 9. So that's all the attach command does. It's saying, hey, pin 9, be looking for pin 9. Or rather, it's saying we're gonna send information through pin 9 to the servo. Okay, the other command we use is write. And this, the argument for this is the angle that you want to send the servo motor to. So right when we start this code, we say, hey, send the servo motor to 90 degrees. All right, let's look at the loop. So we write 0 degrees, and then we wait a second, then we write 45, and we wait, and then 90, then 135, then 180, and that's what this thing is doing. So it's at 0, 45, 90, 135, 180, back to 0. 45, 90, 135, back to 0. And so that's what's happening in this code here. And that's exercise 1. We just want you to see this happen. Okay, so now I want to show you the second exercise. This is about the timing limitations. So in this code right now, we're allowing 1 second between transitions. But what happens if you send the updated angles very quickly? Like, what if I only allowed half a second between these commands? Or a quarter of a second? Actually, let's do that. Well, hold on. Because that's what this exercise is about. So, the first thing that you do is modify the code so that the servo simply alternates between 0 and 180, waiting 1 second. So how about we modify the code to do that? And this is so straightforward. I'm not going to hide this from you. We're going to write it to 0. We're going to wait. And then we're going to delete this intermediate stuff. We're going to go to 180. So 0, 180. Let's see what this does. It's just going to flap from side to side. Boom. Boom. Now what I want you to do with this exercise is start reducing the delay here. Little by little. Like, what if I make this 900 milliseconds, 900 milliseconds, and I'm going to upload that and see if it can still have enough time to do this. Okay, so it's doing it faster. And I want you to like keep gradually backing this down and observe the behavior. Okay, now it's only waiting 800 milliseconds. Now I'm going to jump way ahead. 250 milliseconds. So now it only allows a quarter of a second between transitions. Let's see. Notice now, it never makes it all the way to 0 or 180. Like it starts making progress in one direction, and then before it gets there, it receives a new command and it starts going the other way. And if we make this even faster, let's make it 1/10 of a second, 100 milliseconds. It's probably just going to jitter somewhere in the middle. Yeah. It's just twitching. Oh, it's actually like migrating around a little bit. But yeah, it's just twitching. So this shows you. I'm gonna unplug this. Give it a second. But this shows you an important property of like using a hobby servo motor, and just like if you haven't used this before, you might think that like, oh, if I just string together a bunch of commands really quickly, it'll just complete one motion and then it'll complete the next motion, etc. No, that's not the case. Whenever you update a command, it immediately starts moving towards that other direction. So if you don't give it enough time, it may not perform as you expect. So that is what exercise 5.2 is all about. Looking at these servo timing limitations. And like I say here, this is an issue when large displacements are requested in a short amount of time. Why it doesn't speed up to cover up the lack of time? That's a good question. That's a good question. So these types of servo motors, I think they're always moving at top speed. I think that's basically how they program them. They're always going as fast as they can. So it can't go any faster. All right, let's go to the next exercise. Potentiometer controlled servo. All right, so this one, we're going to control the servo motor with the potentiometer that we put onto the board earlier. So first, you want to open up servo sample number 2. Let's open it up. And let's upload it to the board. I'm hesitant to plug my board back in because it's just going to start twitching, but because it's going to run the last code. But we're going to upload this new one in a second, and it's going to calm back down. Uploading, uploading, uploading. And there it is. Do they make different types of servos that vary their speed? Good question. Well, I would say for hobby servos like this, so this class of servo is a hobby servo. I think they mostly operate on that bang bang control principle, where it's just like it's always slamming as fast as it can go. But this is the most basic type of servo motor, and certainly all servo motors do not just move at a super fast speed. They make servos that have much more flexibility than that. All right, let's just play with this code a little bit first. So notice I'm turning the dial, and the servo rotates as I turn the dial. Now this dial only spins a certain amount, and the servo only spins a certain amount too. But I specified one end of the dial's rotation to be 0 degrees and another end to be 180 degrees. Now what you're going to notice though, as I rotate the dial to the left, the servo motor spins to the right. And now if I rotate the dial to the right, the servo motor actually spins to the left. So its motion is opposite the direction that I'm rotating this. So your goal for this exercise is actually to adjust this code so that the servo spins in the same direction that you're rotating the dial. Let's look at the code, because we can talk about this a little bit. Okay, so here we're specifying that the potentiometer is plugged into analog channel 0. So I just called this the sensor pin. And the signal ADC, this is the analog to digital value that we're getting from the potentiometer. So I'm using this ADC value to command the servo to go to a certain angle. So I'm storing the angle that I want the servo to go in the variable reference angle. Let's go down here. So I attach the servo to pin 9 again. I start with the servo at 90 degrees. Then in the loop, I read from the potentiometer what position is the dial. And then this is the reference angle that I set. I take the signal ADC and I multiply it by 180 divided by 1023. Okay, so the signal ADC, we know that this is going to be a value between 0 and 1023. When I go fully to one direction, it'll be 0. And when I rotate fully to the other direction, it's 1023. So effectively, I'm dividing that ADC value by 1023. So this will be somewhere between 0 and 1, and then I multiply it by 180 degrees. So this reference angle is always going to be between 0 and 180. And then I write this reference angle to the servo and wait 50 milliseconds before updating the next angle. Now the reason that this works smoothly, because you know, like we just did the timing exercise earlier, where if the delay is too small, then the servo acts like really jittery. Well, this only works if you update the dial slowly so that the servo doesn't have to make a huge angular change over a short period of time. Okay. So the problem right now is that the servo's rotating in the opposite direction that I'm turning the dial. So do you guys have any ideas for how to adjust this? So that it spins in the same direction. Try this really quick. Negative sign somewhere? Negative sign won't do it. Negative sign won't do it because it can only go from 0 to 180. It can't go, like if you send a negative angle in here, it won't know what to do with it. Lucas says you could have it start at 180 degrees and go to 0 degrees. Okay, so you're talking about like reversing something, which is it's in the right direction. Something that might help you think about this. You would do 180 minus what is already typed. Ah. You're onto something here. If you're still having trouble like visualizing, hey, what the heck do I do? What I would do is I would print the signal ADC to the serial monitor as you run this code. So what this is going to do is this is going to show you the numbers that are coming off the potentiometer as the code runs. let me do this. All right. Now what I'm going to do is I'm going to open up the serial monitor. And what this is printing to the screen is the current ADC value. So if I turn all the way over clockwise to the right, it goes to 1023. And if I scroll all the way to the left, counterclockwise, it goes to 0. So if you get a feel for how these numbers change as you change the direction of the potentiometer, and this is the signal ADC value, by the way. This will give you a better intuition of like, hey, what do I want 0 degrees to mean? What do I want 180 degrees to mean? Okay. In terms of the reference angle, I mean. Okay, good. So that is the third of 4 exercises. Let's talk about the fourth. First, so this is about timing. Let's open sample code 3. This kind of makes a timer out of your servo motor. Let's upload it. Watch what happens. We're uploading it. Okay, so what it's doing a smooth rotation from 0 degrees to 180 degrees, and it's taking 5 seconds to do it. I think we could time it. All right, where's my clock here? We're gonna do the stopwatch. Right when it gets the other side, boom. Oh no, I started it too early. Oh no, the timing is tough. All right, reset. We're gonna get it right. We gotta be patient. Oh no, I went too early. Okay, so it's not, you just gotta trust me. It's taking 5 seconds, okay? Wait, what if I do the lap command? Oh, that one was right on. 3. Yeah. So we've made a timer. So your goal for this is to change this code. So now it's going to be 20 seconds when it hits the other side. 20, boom. You're going to change it so that it takes 3 seconds to pass from one side to the other. So let's open up the code again. Let's see what's going on in there. Okay. Actually, I want to go into the loop here really quick. So this is what's happening in the loop. It's saying the current angle, or the angle that I want to send to the servo is the angle plus an angle increment. So this angle increment will allow us to increase or decrease the angle. Now, this if statement, it's saying if the angle is greater than 180 minus the absolute value of the angle increment, meaning this is basically saying like, has the angle reached 180 degrees? And then this means or, the double vertical lines means or. So if the angle has reached 180 degrees, or if the angle has reached 0 degrees, so if it's reached the limit, then we reverse the sign of the increment. Like if it was positive, we make it negative. And if it was negative, we add another negative to make it positive. So that's how this thing is changing direction. Once it gets to one side, this if statement gets tripped, and then we change the sign of the increment, and then it goes back the other way. Okay, then we just write the angle to the servo and we delay. How much do we delay? 25 milliseconds. Okay, so this is the puzzle of the workshop. Your task is to change this variable, degrees per second. Well, actually, we don't even really use this variable. I mean, I did before, but I changed this code up a little bit. Really, you have to change this angle increment. And it helps, I mean, you have to calculate this degrees per second to really figure out what this angle should be. But this is what you're solving for. You want this to take 3 seconds to go from one side to the other. And we're updating the angle every 25 milliseconds so it moves really smooth. But how much should you change the angle per 25 milliseconds? So right now it takes 5 seconds to get from one side to the other. So if it takes 5 seconds to go from 0 to 180, that's 36 degrees per second. And this angle increment is saying, well, okay, how many degrees is that per 25 milliseconds? So that's my hint. And that's how we get this buttery smooth motion moving from side to side. So this is just helping you practice with the timing of motions for servo motors, because the purpose of a servo is to do precise motions with precise timing. So there it is. And guys, that is the essence of this workshop this week. It's short, it's sweet, but it gives you the basic idea of how to work with servos. So that's it, my friends. That's all I wanted to show you. If you have any questions for me, I'll hang around for like a couple minutes. But other than that, it's just been a pleasure to hang out with you guys, to get some interactive time in the midst of remote learning. So it's always good to have a little bit of interactivity. What do you say? Man, and the sun is still slightly up. I love that about summer on the East Coast, that it's gonna be like, you know, in a couple months it's gonna be like 9:30 p.m. and the sun will be setting. I love that. Guys, take digital control next year if you haven't already. You'll learn how to control the motor. It's really cool. Hey, thanks, Amin. No, yeah, that's true. We're going to get into the specifics about how to design a very sophisticated controller. You'll be able to control lots of different things. Take digital controls. That's a good one. If you like this stuff, we'll go into all the details. Is that a mandatory class or an elective? It's an elective. It's an elective. You can learn to control a robot, like this self-balancing robot. It's got 2 wheels. Yeah. This guy's one of the examples we look at. We haven't gotten to this yet this semester, but it balances on 2 wheels. Hi, Wally. Yeah. Yeah. So like you have to control the speed of these motors to keep it upright. So that's why, like, we do some of these workshops to just give you like a basic idea of, hey, if I want to command a motor to do a specific thing, how do I do it? And then you can chain it together for more complicated stuff like this. Yeah, it's fun. All right, everybody. That's it for tonight. I hope you have a great rest of your Monday. It's been a pleasure hanging out with you. Peace.